Yes, hello there. My name is Maclean Leah Bialy, and I'm going to discuss to you the model selection and deployment for the trichology application. So in this presentation, we are going to look at the introduction, the you only look once model, that is the YOLO V8N, the faster RCNN model. Afterwards, we shall have a comparison between two of them and which one did we choose and why did we choose that model. And then we shall also talk about our deployment. How can we deploy the model? How can we move from the model phase to the hardware phase and to the point of getting results from the scalp images we shall have gotten. Then afterwards, we shall look at the conclusion. So talking about the introduction, we talked about model selection. When we are talking about model selection, this is not just a machine learning. It's not just a machine learning stage, but we do this because for every successful project, it will have to depend on which algorithm are you choosing. Is the algorithm that you're choosing matching with the nature of data you're having? And if you're choosing that algorithm, will it also help us to solve the problem we want to solve? So in this project, we looked at the different object detection models, which were considered in order to determine a more suitable one for scalp detection. So looked at the main two models, which is faster RCNN and also YOLO, which is the you only look once V8 model. So talking about these models, first of all, we looked at the YOLO V8 model. So this one is a lightweight nanovariant ultralytics YOLO V8. For the fact that there is a V8N, N is for nanovariant, and nanovariant means that this model is lightweight and it is fast and it is so efficient. So it is ideal for real-time scalp health screening on mobile edge devices. And here we can give an example of, for example, if we are having your app, or let me say you're a doctor and you want to take a screenshot or you take a scalp image, then you want a real time result. So this YOLO V8 model will be the best for that case. And if we are having maybe a doctor or this model needs to be used in rural areas or areas whereby the internet is not that stable, then this model would be the best one. So in this case, we had to convert, during our training, we had to convert the annotations we had into YOLO format. For this case, we mean that for the images we had to convert them into the .txt files so that we could be able to feed into our model and it could be able to detect and classify the affected scalp regions. So the performance of the models then evaluated using the metrics such as precision recall, MAP50 and MAP50 to 95. This 50 to 95 is the more strict one than the MAP50 alone. So we looked at the justification. We had a technical justification in that YOLO V8 is fast enough, thus giving instant results. So in case you're having, as I said earlier, in case you're in an area which does not have Wi-Fi or which has poor internet, then technically this would be the best model to use. And also, if you're having maybe you want to catch the super small flakes, or let me say these dandruffs which are just starting in the head, and maybe large patches on the scalp, then this model would be the best. So the combination of speed, independence, and balanced accuracy makes it reliable and practical for nurses and clinics where resources are limited, helping in the catch of scalp issues early without needing fancy equipment or constant internet. That's why we say that if you're in a place with unstable internet or with no internet, then this model would be the best. Then for the scientific justification, we chose this because it has a strong scientific backing in dermatology. Yeah, so YOLO V8 has achieved high accuracy in skin lesion detection, the hair follicle analysis, so it excels at detecting both the tiny microscopic features and large microscopic lesions. And this one helps us to it makes the practical choice accurate and also reliable, increases reliability in scalp health screening in for our case in our setting. So when we talk of the deployment pipeline, how did we do the deployment? First of all, we had the training phase where we trained our model with the YOLO format. Then afterwards, we had to get the best model that we saved. That is the one we saved as the best PT, best.pt model. Then afterwards, we fed it with the what the data set. Then we got a .tflight file. Then it is that .yolo file that we had to feed into the mobile phase app. So this pipeline starts with a training phase whereby the model is fine-tuned on custom dataset. And after training, we export the best model to TensorFlow format, which file runs efficiently on mobile devices. So the file is then integrated into mobile app phase built with Flutter. We use Flutter because it supports both iOS and the Android. So looking at the deployment pipeline, we also had the YOLO architecture. We know that YOLO has only, it undergoes only one state, like it only looks once. So as we are training, the model just look at the given image, and afterwards it gives a prediction immediately. So here you input the image. We have the input layer whereby, if for our case, you can get a camera and you just you take a picture of the scalp image. After that, that will be the input layer. That's the first layer. Then for the second layer, we have the backbone, and this one involves feature extraction. Here we mean that it will look at the near features we're having. If it's the scalp, it will look at the texture of the hair. It will look at the flex. Those are the starting dandruffs, the dandruffs which are starting, the tiny ones. Then it will look at the inflammation patterns and also hair density differences. Then the third one will be the neck. The neck layer, that is where we are having the multi-scale fusion. So this one's combining the shallow and the deep features. The shallow features are those ones which are found at the backbone, which are gotten by the backbone. Then for the deep features, these ones are call them the larger scalp condition areas. Then the other layer is the detection head, whereby it just predicts the bounding boxes, the class labels, and also the confidence scores. Then last we'll have the final output layer. This one gives us the final output of everything which has been detected. So it detects the scalp condition regions, the disease class name, and also the confidence score. So after that, we have also the FASTA CRINN. So this one is a two-stage object detection architecture. Remember, for the YOLO, it was a one stage, but the FASTA RCNN is a two-stage. What do we mean by two-stage? It means that for it first detects the regions with the conditions, okay, with the scalp regions which are affected. After detecting those regions, it will then classify them. So after classifying them, then it will work out with the classified images. So here we are saying that afterwards we had to compare it with the RCNN with the YOLO. So the important architecture difference is that FASTA CRNN is a two-stage, while the YOLO is a one-stage. So FASTA RCNN proposes regions, then classifies them. That's what we said. But for YOLO, for it predicts boxes and classes in a single forward pass using backbone and neck detection head. Then FASTA CRNN was extremely slow on my machine. Yeah, for it was so slow. So I had to use the YOLO. I had to deploy with YOLO because I was running my code in a VS Code. So my my model was running on CPU and it was taking longer than ever. And we literally needed a GPU. So I I I know that the faster CNN would work so much if we need so much detailed object detection project. But for our case, we are working with a project whereby we need instant results. In case a patient has come into the hospital and you take an image, that patient won't need you to first look for Wi-Fi or to first look for maybe other hardwares. The person will be needing instant results. So for this case, that's why we had to choose the YOLO. So these are our interfaces whereby after someone someone can, let me say a nurse or a doctor will open their desktop and this will be the welcome page, call it a login page, can be able to upload the image, detect condition. So someone can decide to tap the login button and we'll get this dashboard. So in this dashboard, we shall also have the conditions detected. They will be summarized here, the total scans, average confidence, and the current model. So this one shows the table showing current scans. Then, we are having the so here we are having after logging in, you'll have this dashboard whereby you can search for anything you want. Then here we are summarizing the conditions which have been detected so far in our system, then the total scans we've made in our system, the current model, of course it will be the YOLO V8, and then the average confidence, how confident is the other results being gotten. This one will be a table showing the current scans. So afterwards, someone can choose to go to the upload. After tapping on this upload image, so we're talking about this. After tapping on upload image, you will be asked to choose a file, which file will be uploaded into this space. Then here you can decide to preview your image. Then after previewing the image, we shall get the details about the image we've uploaded. So here we can maybe it is an image of maybe a scalp, the MBs, the history about it, like when was it taken and stuff like that. Then afterwards, you can decide to run the detection. So when you run a detection, we see that it will show that it's loading. We're having something in progress. So afterwards, it will show that image received. Then we shall have to generate the result. So on getting the result, it will show the upload scalp image, the confidence levels, how sure are we with the results you're getting, then the conditions detected in the scalp. So we shall have also a summary of results. You can decide to save the result or you can decide to download a report of the result, depending. So in conclusion, in this project, FastACRNN helped me to understand the region-based object detection, because remember, for it is a two-stage detection model. But for YOLO, for it is a one-stage detection model. But after understanding both of them, I had to select YOLO because it was the better practical choice for this condition data set, because it was faster, easier to train, and easier to evaluate on my machine. Faster RCNN took almost a full night just running, training the model. So it was so slow to evaluate on my machine, which was otherwise with YOLO. YOLO was slightly faster than faster RCNN. Therefore, my model selection was the YOLO V8. Thank you for listening.